Hey, what's up, Blake? How are you doing? Good to see everyone here. Who's all here today? We'll start with a little music. Got a little chill start going right there. But who's all here? Say hey in the chat if you're here. Just chilling out, getting some ready to work. I don't even know what we're doing. Got all the coffee this morning, so woo, all the coffee. Getting everything ready to go. New intro time? Yeah, I'll play that one next week. We'll switch. Let me switch back to Rocky Top. There we go. Oh, that's the wrong one. There we go. I got the intro. I got the other intro queued up. I've got it all on my Stream Deck, so I can switch. Someone's like, someone asked me, like, how do you do that? To like change them that quick? And I was like, oh, I've got like every intro queued up. Saved by the Bun. Yeah, it's got the exclusive sneak peek for next week. Exactly. I like it. Get that sneak peek. It's I want it to be fun, you know. This might sound crazy, but it's like when I was like thinking, I was like, oh, I get to teach students. I was like, I can make class fun. I can make school like something. I don't know. My in-class classes are like this too. I jump on desks and stuff. Maybe I shouldn't jump on desks, but like, I don't know. I don't want to be a boring teacher because then I'm bored. Like if I'm I don't know, nothing against other teachers, but like when you're teaching and you're just like reading from a book or something and you're just like blah, 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 jumping on desk to improve test scores. Exactly. It's a very good explanatory variable. It gets people's attention. So yeah, maybe it does. Maybe there's evidence of that. Maybe we could do a statistical study to see if a teacher who jumps on the desk versus a teacher who doesn't, but we have to randomize. We have to randomize the students and we have to randomize the teacher who jumps on the desk. So that's you do randomness and then you do a trial and you do a test and all these things. And yeah, it'd be pretty crazy. I don't know. What do you think, Blake? What should we do right now? Should we do some Stat Tool 1? Where's Mubot? He's awake, isn't he? He's chilling right here. Say hi to Mubot. Let's give out some points. He should be awake. He's always there in the background. Chapter 8, what do you want to do chapter 8 wise? Oh my gosh, wait,
I am always here, Blake. Mubot is here. Good to see you, Thomas. Now I'm evil Mubot.
What are we doing? Quiz has me struggling in chapter 8. Too bad. Stream. Over. No more. Please help. Mubot says so. Why am I so low? 1 second. There we go. No more Stat Tool 1.
Mubot, he's gotta stop doing stuff like that. Let's get some chapter 8 quiz going. All right, here we go. Let me get some chapter 8 quiz going. Okay, I'm loading up the quiz right here as we're talking. Chapter 8 quiz. We're talking about putting some bonus on this because I think there's one question that talks about influence points. Maybe I'll mention that today. I could mention it, but I'm voting for we put some bonus on here. I said, let's add a little bonus to the assignment. I said, there's a question that goes a little more in depth than we went in the notes because we added some new questions this semester. So apparently one of the questions is a little more in depth. One of them. You could get that question. Maybe we'll look at that question. So my vote, I said, let's put 5 points bonus on that. 105. You get up to 105. You get 5 attempts. Mubot canceled everything. Mubot is always canceling us right there. Hey, Corbin, good to see you here. Ask any questions if you got them. Which question are you working on? The accompanying plot output shows the Federal Reserve. Okay, we got it right there. The accompanying plot. And I have meetings today, so I canceled afternoon office hours. No, so there's only morning office hours today because of meetings. Those darn meetings. Meetings. Ooh, that's cool. I'm a scout poll. Quiz 7, question 3. What does that say right there? What does that say? Because the quizzes are different each time. So we'll find that one next right here after this one. I think this is a chapter 8 one. Here we go. The accompanying. Hey, Jackson, good to see you here. Mubot can cancel the meetings too. I wish Mubot would cancel meetings. That'd be nice of Mubot. That'd be very, very nice of Mubot. So, Mubot, if he could, he would, but he can't. Okay. Let's see what I have open right now. Closing down some stuff. I have the first question found, and Corbin, drop the other question in here, because every time you take the quiz, it is different every single time. Every single time you take the quiz, it is different. So the table shows the live births, the population. The birth rates one. I think we've been doing that a lot. We'll do that one here soon. We did it twice yesterday. We'll do it again. We got this. Let's do it. Okay, here we go. A little chill music as we finish up and put the note. 7:03. You got it, Corbin, coming up here next. Good to see you here, Morgan. Stat 201, Chapter 8, Quiz. The accompanying plot. Accompanying, I can't spell accompanying plot. All right, let's do it. Here we go. We're working on some Chapter 8 quiz, then we're doing a little Chapter 7 after this. That question that Corbin asked is probably one of the top questions to understand. So here we are with the accompanying plot, and regression shows the federal rate of 3-month treasury bills from the years there. A regression model was fit to the relationship with rate in percent since 1950. So we're going to see like a 0 to start. If you look down here, there's the 0, and it goes through 30. Okay, what's the first thing you notice right here? What is the first thing? I'm going to make sure it's in my copy-paste. What is the first thing you notice with this graphic? When you see regression, what four phrases pop in your mind? When you see regression, what pops in your mind? Okay, positive, I got it. So you might be thinking this is good stuff to think about too. Strength, direction, form, unusual features. That's decent right there. It's QQ, I like that. QQ, that's where I was going. QQ, straight enough. No outliers? But don't worry, we're gonna go somewhere else with this in a second. No outliers. But probably we might have an issue of what? So there it is, right there. QQ, straight enough, no outliers, plot doesn't thicken. I think we have an issue of plot thickening. Plot thickening is when at some points the model gets thicker or thinner. That's maybe where the question is going. I don't think there's a straight enough issue at the end of that, but strength, direction, form, unusual features are the 4 ways to describe correlation. But we're mainly talking about regression right here, which is going to be the QQ, 2 quantitative variables, straight enough, no outliers, and plot does not thicken. Plot does not thicken. Yeah, I think so. That's maybe where this question is going. This is a new one for me this semester, but I always like to kind of look at it and think, where is it going? What is the correlation? Did it give us correlation? It gave us r squared. How do we turn r squared back into correlation? So now we have r squared. And so be careful, this one's not a tricky one, but what are the steps with r squared to turn it back to correlation? Correlation ranges from -1 to 1. You got it right there. And Corbin and Blake, great work. Everyone following along. Really huge shout. Thank you to everyone here practicing. The more you do this, the more practice you get. And then you're like, oh, r squared is out of 100%. We turn it back to a decimal. So that's the first step right there. R squared needs to go back to a decimal, no longer be a percent. And then we square root it, but there's one last step. There's one last step, and we're actually okay on this one. One last step right here. What is the last step after you square root r squared? Which was on your Canvas content. 6 people right there watching. I like it. Oh, thank you so much, Shelby. I guess this is helpful, right? I hope so, right? Because I'm hoping this helps everyone out. I hope Shelby's saying, like, this is helpful right here. Because we're just practicing. We're just learning right here. Because now what do we do after we square root r squared? We have r squared square rooted. Thank you, Shelby. It's really, I love all that positivity. What do we do after we square root r squared? There's one last step that people, I made this mistake yesterday. I mean, I was saying it. I was saying we have to do this, and then I didn't do it. I was still jumping on tables. So after you square root r squared, look at the what. Look at the what of this. Look at the what of this. Oh, good. Shelby, we like those answers right there. We always say, if you have no idea, just say it. 1,000 points right there. Look at the what after you square root r squared. The direction. After you square root it, look at the direction. Blake, I think, was here yesterday when Brian made the mistake. And so make sure to look at the direction. So when you square root it, you'll get a positive number because r squared is positive, but you need to look at the direction to make sure it is positive or negative because correlation is -1 or 1. So it goes from -1 or 1. So we know it's positive right here. Whoops, thought I copy pasted. And so that is the correlation right here to 2 decimals. We just delete down. There we go, 2 decimals. Nice. The birth question. We can do the birth question here next. Interpret the slope and the intercept. So what do you need to know how to do for your tests? On the test, you need to know how to interpret the slope and the intercept by writing it out. So on the test, you want to try writing these out. So I'm going to look at the slope at here, and the slope is down here. The slope is this variable. So for each additional year after 1950, we expect the rate to increase by 0.247% on average. So for each additional x, for each additional 1 unit increase in x, we expect y to increase by b1 on average. So let's look right here at the slope interpretation. And I think it was, oh, and then they're doing the starting at. So they're including the intercept at a starting point. On average, interest rates during this period increase, at about blank percent per year. So that is the coefficient of the slope, 0.248. How many decimals? 2 decimals. So I think 0.25. Let me double check. And it is in a percent already. 0.25 right there. Starting at a rate, so they're talking about starting at the intercept right there, which the intercept is 0.61. I'm too afraid. Tell me if I get a decimal wrong. I do make errors every once in a while. There goes that. What does the model predict for the interest rate in the year 2036? This is very similar to the birth rate question, because with this question right here, what do we need to do to 2036, which is only 14 years from now? What do we need to do to the year 2036 to turn it into a value we can predict from? Because we're doing years since 1950. So, hey, Taylor, good to see you here. So we're predicting for 2036. And this is years since 1950. So we're predicting for 2036. So that means when we write out our regression equation, we need to what? So let's grab the regression equation down here at the bottom. And let's write out the regression equation. The regression equation is the rate is equal to the intercept plus 0. The slope times, and then x, which is the years since 1930. We can do it here. We got one more after this, Taylor, and then you got it. We can do it next. You bet. So what are we going to do right here? What do we need to plug in? Remember, we're predicting for, so let's put the value we're predicting for. We're predicting for 2032. So how are we going to make a prediction for 2032 right here? So the x is years since 1950. So how would we square rooted the r squared. We square rooted the r squared. For the first question, we square rooted the r squared, but make sure to put that to a decimal. So it was square root 0.776. And then check the direction. You're welcome, Shelby. Great job. And so how are we going to take this value and input it into the x right there, which is the years since 1950? How are we going to input that value into the x? Don't input it as is. Exactly. Yeah. Great job, Corbin, right there. That's exactly it. It's 82 years since it. 1,000 points, Corbin and Shelby right there following along. So we're going to just change it to the years since 1950. And so this value right here is going to be, when we plug it in, is going to be 82. Tell me if I make a math error. It's going to be 82. And so that's just the years since 1950. So usually the way I solve these is I go right here. I times 82 times the slope. There we go. And then I add that to the intercept. Since it's positive, if it's negative, make sure to subtract. And don't make a math error. It's very easy to make math errors. So 20.94, yada, yada, yada. Okay, so that's got that one. And okay, what does it predict to 2 decimals? 20.94. Okay. Would you expect this to be accurate? What do we call it when we go outside the x bounds of our model? What do we call it when we go outside the x bounds of our model? When we go way outside, when we go 50 plus years beyond the x bounds? We call it extrapolation outside the x bounds of the model. So let's see if any of these answers down here. Great job, Blake, right there. 1,000 points. Blake getting those points. We give everyone here points. So we're talking about some extrapolation. So not really extrapolating just right there. extrapolating is not a good thing. You don't want to extrapolate that far. Yep, 320. I'll be teaching 320 next semester. Join on in. It's a lot of fun. We'll be doing some R in our studio. Did we get all those answers right? Oh my gosh, what did we do wrong? Did we get a decimal place error again? That one's obviously right. Increased by this much, We should have that. What did we do wrong? 2 decimal places? Where did we go wrong? That one's right. This one? Don't tell me I did the math wrong right there. That one's wrong? Okay, what did I do? What was the error? Who sees it? What is the error? I need someone to, this is for 2,000 points. No, we're not banning it. It's Brian doesn't know how to math. For 2,000 points, what's Brian's error? Catch Brian's error. What is Brian's error? What's Brian's error? Catch my error. I just do it to see people are paying attention. I swear. I swear. Not rounding. It's not rounding today. It's not rounding. Catch my error. What's the error? Look over the question. See, where did Brian make his error? Someone should see it. Give it a few more seconds right here. Yep. Because I input 2032. So what should I do instead now? So instead 2,000 points right there. So what should I do instead now? Like, think about it's still the same thing. It's still conceptually we're doing the right thing. Oh, we got some really good stuff right here. Oh, is that chapter 7 or 8? So tell me which chapter so Shelby and Corbin and everyone, great work. I think we'll do Corbin's. We did the birth. We've done the birth one twice yesterday, so we might try to do some new ones here, but I think we've done a lot. We'll try to do all these. We'll do some chapter 7 next. I think that's people's big stuff. So we plug in 6, that's 4, so 1. So it should be, did I change the number? What did I find when I got this? I got that, okay. So it should be about that. No! Really? Okay, let's solve it. All right, let's actually plug in the number 86. I'm a little worried if it isn't, because it should be about that. Yeah, exactly. Stop guessing. I know, right? We're just digging our hole deeper. We're just digging that hole. There we go. It wants a very exact answer, I think. Or is it actually having me use the regression? See, 21.94. Is it actually having me use the regression equation with these numbers? No, is it actually having me use those numbers? No. Don't have me use those numbers. 86 times. No. Do you have me use the rounded numbers? If you got this one wrong because you didn't use the rounded numbers, then just let me know. It wants you to use, no, so what it wants you to do is it wants you to use the rounded numbers, but if you carried through the decimals, like I did right here, then one of the officers had no timestamps. Which one was that? Is it yesterday's? I might not have timestamped it. Yeah, it might still be in here. I could go do that right now. Might be yesterday's. Sorry about that. That's my fault. Content. Live. Yeah, I see it. I see it right here. Okay, we got 2 seconds. Now we're going to do another question. Okay, let me throw those in here. This thing right here. We're getting some timestamps. Wait. Okay, good. That's that one. Okay, so now the officers have timestamps right there. And this also has timestamps. There we go right there. We got it. Good to go. No, thank you for mentioning that, Shelby. Sometimes I get really busy at night replying to emails and stuff, and so I forget the timestamps. because I take them while I'm doing it. I used to spend like an hour like redoing the videos and trying to find timestamps, and I would try to like. So I started doing the segments between. We'll do some chapter 7 right here. But this is why I started to cut to these screens right here between, because then I would like look for this screen. I'd scrub through the video and try to find the screens and be like, oh, didn't I do a question here? And I'd miss a question every once in a while. So nowadays, I literally just take the timestamps live while doing it. So that way, all I do is I have to just load up the video, which I was able to do just in a minute or two right there, and do it. But sometimes at night, I'm replying to emails or something, and then I forget to throw in the timestamps. If I was a real pro, I'd do it right after. Sometimes I do that. Like sometimes, especially on test days, I'll get the timestamps going. So if you reload that video, it should have timestamps. I think all the videos have timestamps now. Yesterday's video didn't have timestamps. Thank you so much, Shelby, for mentioning that. We want those videos to have those timestamps. I think they're super helpful. I think they should all have it now. Let me double check, because I just deleted timestamps. Live videos. Yes, they have timestamps. Everything looks to have timestamps. Nice. Nice. Because they get utilized. Like, it's pretty crazy. We got a comment on one of the officers' videos. Oh, I think you ever did that. Maybe they said no timestamps. Where are the timestamps? Where are those timestamps? Oh, thank you so much, Shelby. That'd be so funny if the one comment. It'd be pretty funny. We're doing chapter 7 quiz. It is your call. If you are here right now, you get to pick which question we do on chapter 7 quiz. I will do any question on chapter 7 quiz. We've had a lot of those questions. This is coming due. I think it's the 20th, right? So it's tomorrow. Oh, just closed it down on me when I went back to look at the due date. It is the 20th. Yes, it is. I'm reopening it. First questions you mentioned on chapter 7 quiz are the ones we will do. So mention them. Which one? Have you done the manager of a bookstore wants to predict sales? The manager, boom, we got it right here. Let's do the manager at a bookstore. Here we go. Yeah, no, let's take a look right here. Manager at a bookstore. And I think there's a few of these. So we will do the manager at a bookstore. And tell me if you have a different version. But manager. Good to see you here, Jackson. Manager at a bookstore. Whichever questions you say right now, we'll do. And there's a lot of other ones. But if you're here right now, wait, it's actually chapter 7 homework. Is there in it that the animal gestation we're going to do animal? You want to do the homework one instead, Shelby? So Shelby, the homework instead, because the homework can be a little bit different. So let me go get the homework version of it. It just closed it down. I left that quiz. Looking at my stream deck right there. Homework version coming up here in just a second. Once my Pearson loads back up. Come on, my Pearson. There we go. And now the homework. What homework has the same numbers? So you can actually tell me the homework number, like numbers such and such on the homework. So you can actually tell me the number on the homework. It actually has the same number. Number 7? Okay, cool. Homework's always the same. Quizzes dynamically change. Okay, so this is R squared right here. We did this one yesterday too, but don't worry. We're here to practice. So R squared is what? Don't even look at these answers. Don't look at these answers. What is R squared? Before looking at any of these answers, what is R squared? So what is R squared? What is R squared? What is R squared? What is R squared? R squared is what? I know people might just be looking for, don't worry, like knowing the answer is one thing. Well, it might be 0.5, but what is it? What is it? Oh, so R squared is how well we explain the data. So it's the percent of variation in Y explained by the variation in X. So I'll repeat that again right here. R squared is the percent of variation in Y. It's also R squared. It's correlation squared. So R squared will be, the point is not to get this question right. The point is to know what R squared is. Like, that's the point of this question. So R squared is blank percent of the variation in Y is explained by the variation in X. So I just want you to look at it visually. You ready? If we were to have something down here, a graphic like the following, where we have people and sales. If this is our data, how well does people going from 1 to 10 explain our sales going from $0 to $1,000 in sales? how well does people explain the sales? So look at the relationship the data has. You'd probably say there's what relationship? So what would you say right here? R squared is the percent of variation. So what might R squared be close to here? Like, think about what R squared means. It's like how well X explains Y. So does people look to explain sales right there? Does the amount of people, which I think is the context of this problem, does the amount of people look to explain sales right there? Yes or no? What do you think? Just visually speaking, like as you notice people increasing over here, does that look to have a relationship? No, it doesn't look to have it. It looks to be completely random, right? So in this instance, R squared would be around 0. And think because correlation is probably close to 0. So, yeah, it's supposed to be random. Yep. The relationship looks to be by random chance. And also, one last thing we could say here, the p-value is probably close to 1, which means it's highly likely by random chance. Now, the kind of reverse of this is going to be where you have strong relationships, which we could have the same sort of data right here with people and sales. So now what we'd probably see, and I think this problem shows, is probably you'd see a relationship right here where the line goes up and the points are around the line. Now, if you look at it, this line explains the data, or the relationship between X and Y is linear, and now we might see values of R squared closer to something like, let's say, 0.81. And then correlation would be what? R squared could also be interpreted as a percent, as 81% of the variation in sales is explained by the people who are working, but what would correlation be now? What would correlation be? What would correlation be? So unwork the R squared back to correlation. It'd be 0.9. Shelby, great work right there. Getting us some more points. It'd be 0.9. So now you could find the correlation. Now then, always, as you've probably done, check the direction. So you did the right thing right here because it is positive. So it's going to be 0.9 is the correlation. And then the p-value would be closer to 0 because this is unlikely by random chance. This is a non-random relationship between X and Y. This is unlikely to see by random chance. So we see here that there is a lot of variation explained by the line. There is a high correlation between people and sales, and the relationship is unlikely by random chance, which we would actually look at the p-value of the slope of the line to look at that. This would say 81% of the variation in sales is explained by the amount of people we have working, where the top one right here would say, that's a 4R squared, the top one would say 0% of the variation in sales is explained by people working. So it's important to know how to interpret this because this is just a very simple question where you have to find the R squared down here. They give it to you as R. So we're going to take the R and square it. And then it basically looks at the XY relationship, so 90% of the variation. So the R squared is the percent, or R squared is blank percent. So how many decimals? 1 decimal. Let's check. That's where I got it wrong yesterday. 90% when you round. Ooh, no. Watch. Oh, no. Look at this. 90.1. 90.1, because that's going to round right there to 90.1. So 90.1% of the variation, which is the percent of variation in sales, because sales is the Y variable of interest, that can be accounted for by regressing. Oh, I hate the mathy talk right here. No, so it's going to be A or C. Let's look at A or C. You ready? A or C. It's 90.1% of the variation. Let's just put that right here. And then we have to choose between A or C because we're trying to understand the variation in sales, not sales workers. So first one says 90.1% of the variation in sales that can be accounted for by regressing number of people working on sales. No, you regress Y on X. So it's going to be, and we'll highlight this right here. That's what I did yesterday, but then I didn't round properly. So the way this looks right here, and I don't like the way they word it. So if it was negative, exactly, Shelby, right there. If it was negative, it would be negative 0.9 if it went downward. So the way this reads is the variation in the Y variable regressing Y on X. So this says the Y variable of interest, regression of Y on X. So that should be right there. It's a little more mathy than I like. Well done. And so how would I prefer that to be answered? I would say this is my answer, especially for the test. 90.1% of the variation in our sales is explained by the variation in the workers. 90.1% of the variation in sales is explained by the variation in workers. So blank percent of the variation in Y is explained by the variation in X. You see it right here, 90.1% of the variation in sales is explained by the variation in workers. So does that make sense, Shelby? Like for the test, to know blank percent of the variation Y is explained by the variation in X. Just like, like get it down, practice it. So that way you know how to interpret it, and it's basically how tightly clustered the points are, but it doesn't talk about the direction because the direction is something dealing with correlation, where you could have the same sort of graph right here, Shelby points out, where it would look something like this right here, and it could be the same points, but now you could have an r squared equal to 81, so it does the same, but the r is equal to negative 0.9. So that's what you were getting at, right, Shelby? Is I could have the same r squared technically, so it would look the same scatter-wise around the, probably typically the same. It could look a little different, but it would have to have the same r squared calculated, but then the direction is indicated by the correlation. So note the difference right here where this one has a negative direction going down and this one has a positive direction going up, so it's positive 0.9. So correlation indicates direction, where r squared is just the percent of variation explained. Correlation is not r squared. Like an r squared is not correlation. They can be used to find each other, but they're not the same concept. They're used differently. So that's got r squared. Really good talk on r squared right there. Like that is just a whole lecture on it basically and interpreting it. You have, why is Brian so laser focused on you knowing this up here? Why am I so laser focused on you knowing this? Can anyone tell me for 1,000 points, why am I highlighting this right now? Why am I so laser focused on you knowing this? Because I'm sure, like, put it this way. 12 points on the test are interpretations. Disk drives, let's do the disk drive one next. So that is 12 points on the test, not that one question, but you need to know how to, great job, Zoe, right there. You need to know how to interpret it for the test. 12 points are interpretations on the test. There's 4 points for interpret. I mean, I think we can say that. You have to interpret r squared on the test, so know how to interpret it. Blank percent of the variation Y is explained by the variation X. Disk drives, let's do it up here. Thank you, Taylor, right there. Perfect time to ask the question. There's never a bad time, but sometimes there's a perfect time. So we got disk drives right here. Stat 201, Chapter 7 quiz. Disk drives. Okay. We're about 34:03. I need more coffee. Okay, I got it right here. Disk drives. Got to load up the quiz real quick. Know how to interpret that r squared. These quizzes are really great practice, and these are the first few sets of quizzes we have since the test, so start early. And thank you everyone here starting early if you're watching this in the future. Just remember, some of these are tricky. Every once in a while I get a question wrong, so it happens. You get 5 attempts for those decimal errors, but if you get a little decimal error, let me know. Just be like, hey Brian, I got a decimal error, and I usually fix it up. There are some, remember, if you get a negative where it should be a positive, and then Blake, remind me, we'll do that one next right here. If you forget to do the negative on the correlation, that's not a decimal error. No. Finding this one. Is there any evidence that the... Oh, gestation. Let's do gestation next. Yeah. I'm going to put that in the notes right before I go to this one. Finding the disk drive one. Where's the disk drive? Disk drives. Found the disk drives. Is there any evidence? Animal gestation period. Okay. Chapter 8 quiz. I'm marking this in the notes, Blake. Chapter 8 quiz for Blake coming up here next. Stat 201, Chapter 8 quiz, animal gestation period. We got it right there. We're going to re-timestamp this one. And here we go. Let's do it. Okay, so we've got disk drives have been getting larger and larger. Did you know a 4 terabyte disk drive costs $443? It doesn't. It costs like $100. Maybe, I don't know. Maybe it costs $20 now. Go down to the dollar store, get a 4 terabyte drive. Go to Wish. Don't go to Wish. Not endorsing them. So, tells you about some disk drive space. It wants what is the value of r squared to begin with. So with this right here, what you want to do is you want to bring this data where? If you have data like this, copyright claimed right there, get some DMCA. What do we want to do with our data? If we have data like this, we want to bring it over where? Where's going to be the easiest spot? Boom, Blake knows right there. We're going to bring it over to jump. So what you want to do, watch the steps right here and pause the video if you need it. You can always pause live, just hit spacebar on your computer. So you want to click right here, boop, and then you want to click copy to clipboard. Boop. And from here, hit Control or Command C. Hit it a few times. Then click Done. Now you want to go into Jump, and you can be anywhere inside of Jump. So just go inside of Jump right here, and then go to File, New Data Table. File, New Data Table. Blake, you are a pro at this now. Oh my gosh, I'll throw the points here in a second. Blake's a pro dropping those. Blake, that's worth some 5,000 points. Everyone give shout outs to Blake if you're here right now. Blake is literally dropping. Oh, I can't. 2 seconds, Blake. Now that you have a new data table open, you want to paste with column names, as Blake has put in the chat right there. Now, one big thing to note is sometimes you don't paste with column names. Sometimes you don't. You want to look at your data and see if it had column names. There are a few instances on a few problems where it doesn't have column names. If you paste with column names or don't paste with column names, check out how the data looks. In this instance right here, you'll notice we should have pasted with column names on the left. Does that make sense? Like on the left, we made an error. Now, Blake, how do we know if our data was pasted correctly? Remember, we have quantitative data. So what is one thing we should look for? And there's the points. Huge shouts to Blake right there. Jackson giving the shouts. How could we look at this and know on the right we pasted correctly with column names? Blake knows the blue right there. Blue means quantitative. Notice how the first row right here, which is the first observations, is where the column names are at. That is an error. Don't try to fix it. A lot of times people will try to undo it and repaste it, and they'll get a bunch of errors. So don't try to fix it. Just start over, start a new worksheet, start the process again. Yeah, and then we had to do some craziness. We've done some crazy, interesting stuff. But we got the data in here. So let's say you're just having a really hard day and you can't get the data in. What is one alternative if people can't get that data written in there? What could they do? You could just go and type the values in. You could just literally type the values over here if you want. You can just double click the column, type the values in. Not the easiest, not the funnest way to do it, but you could just write the values and then just don't make an error typing in the values. Easier to paste them in. That way you know you get them right. So now that we've got the data pasted into Jump, we now need to do the regression analysis. Let's go right here to Analyze, Fit Y by X. Analyze Fit Y by X. This is Analyze at the top of the screen. At a Mac, it'll be at the very top. You'll have to highlight the bar. Analyze Fit Y by X. You will put in the price of a hard drive as the Y variable of interest and the capacity as the X variable for the explanatory. So we're asking, does the capacity explain why it is a certain price? Always think about saying it that way. Does capacity explain why it is a certain price? So here we are. This is a somewhat linear, we'll look at the residuals here in a moment, but it is a somewhat linear relationship. I know you say, well, Brian, that looks perfectly linear, but wait. Let's go to the red arrow and fit the line. So this is going to fit the regression line to the model, which is going to write the regression equation for us. The regression equation appears immediately below with the intercept first, which is B0. Next, we have the slope, which is B1. Really nice slope, about 100. So for each additional terabyte, we'd expect the price of a hard drive to increase about by $100, where a 0 terabyte hard drive, which would not exist, so the intercept is not interpretable, is expected to cost around $18.03 on average, 18.04 if we round. Now we get the R squared right here, and we get other values. Can I actually add correlation? Darn it. I thought for a moment I could add correlation. I'm kind of bummed I can't. So I think it might ask R squared or correlation. I can't remember. But this is the regression model, and I do want to point to one thing. I mentioned the residuals. We're going to go here to the linear fit and go to plot residuals. What do you want to see in your residuals? What do you want to see in your residuals? You want to see no patterns. We might have enough time, Morgan. We'll try to, drop those questions. We could try. We'll do it after Blake's question here. So if you notice, there's this really weird bendy pattern, a really extreme point. So the residuals, it's harder to see, and that's that extreme point right there that's really far away. So we might have a bit of issues with this. The residuals don't look so good. All models are wrong. Some are useful. So maybe we got a little bit of a problem right there. What is the value of R squared? The value of R squared is found by going right here and looking at the R squared, 0.9854. So it rounds to 2 decimals, 98.54. Interpret what the R squared means, 98.54% of the variation in the Y variable of interest, which is price of these disk drives, that can be accounted for by the linear model on the X variable, which is capacity of the drives. And is that it? That's it. So it's just another interpret R squared question, but also find R squared. So there's much more detail this problem could go into with looking at the residuals and seeing if there's a problem, interpreting the slope, interpreting the intercept. So definitely think about, what can you learn from this? We can learn that generally we see a positive relationship between the size of a hard drive and the price. There is a little bit of oddity where it's not totally linear. What's really cool is you can actually fit polynomial models to this. I wouldn't suggest fitting, that's an overfit model. I wouldn't suggest fitting something that crazy. But if you ever want, try clicking some additional buttons inside of here, because you can get, that's an R squared of 1. So think about this. Blake, what does this mean that this is an R squared of 1? And this is what we call an overfit model. Morgan might know about some overfitting. So what does this mean that this has an R squared of 1? This high degree polynomial model now does what to those points? And think about why it does this. Think about why this has an R squared of 1. That polynomial model does what? Because look at what it's doing. It's touching all the points. Yeah, no. I used to think this was a great idea. Like, whoa, we've done it. We got an R squared of 1. So no, this is a horrible idea. This is no. This is don't fit this model to your data. Don't do this. That is not the model you want to fit to the data. This means that we've explained 100% of the variation. 100% of the variation in the points is now explained by the model. But this model is horribly overfit because we extracted too much information. It has too high variance, to use the 474 terms that we use. We took too much info out of the model, out of the X's, and so we wouldn't want to fit a high degree polynomial model. Someone could rationally say maybe fit a second order. So Morgan, what would we need to do? I'm doing a little 474 at the end of this. What should we do to check our model at the end of this? Like if we fit this polynomial model right here, which explains about 99% of the variation, what should somebody do with this polynomial model to check, see if it works? Test it on a what? So what should they be doing, and should they have created with this polynomial model right here to see if it actually works? Like there's a lot of things they should do in our process in 474, because we should have made a training and a holdout. You should separate your data into train and holdout and validate your model before to see if it works, and then test it on the holdout to give it a final check to ensure it has, like, you could use the RMSE. The RMSE is right here, root mean squared error. So typically when we predict the hard drive price, we're off by typically about $20. I could probably predict a hard drive. I don't know, 2 terabytes, $80. Western Digital, 2 terabyte, $80. I'm probably off them less than 20. Google that here in a moment. Let's see right here. Blake, we're going to do Blake's question. We're going to try to do 474 real quick after that. Give a little help with that. Here we go. Blake's question. There's so much cool stuff. If you guys can't tell, I get so excited by stats. Like, I love it. I love stats. It's so cool. It's a way of understanding the world. It's data-driven decisions. It's facts and logic. I'm sadly all about them facts and logic. I just say, give me some data. That's what I say. I say, I need data. I don't want data. I need data. Because I'm an adult. I have responsibilities. I have to make decisions based on data. Why make decisions? I love stats because, thank you. I think we have. Did I post that? We should have it posted. So I'll make sure that's posted before the Kahoot tonight, and I'll advertise it. I do have a little quiz. It's very short, but I do have a little quiz. So we'll make sure that's posted right here. Probably post it right after class, or after the 201. Little practice preview. Gestation. Then we'll advertise it during the Kahoot. We'll say, check it out to practice. I would not suggest, the test is open. I would not suggest taking it yet. We've covered all the topics, but especially when it comes to things like, ooh, that's a cool graphic. When it comes to things like, there's the gestation. When it comes to things like check regression, definitely some review is going to help. Animal gestation right here. And then a little 474. Here we go. Let's check out animal gestation. Let's do it. Okay, is there any evidence that an animal's gestation period is related to the animal's lifespan? The scatter plot shows gestation period in days versus life expectancy in years for 18 species of mammalians. The highlighted point on the right represents humans, complete parts A through E. What do you notice immediately about humans? Humans is immediately a what? What do you immediately notice about humans in this graphic? The first thing we do when we look at data is we look at it. It's implied by saying when we look at data. What do you notice about humans over here? First thing you notice. Look at the data and we got a little QQ straight enough. No outliers. So if we lose that. Humans is very much a what to the original relationship. They're much an outlier. They're very much an outlier. They have undue influence on it. So that's when you see, if you see the term influence, influence literally means it influences the line, things that are outliers far away from the bivariate relationship, which there's generally a positive linear relationship that's actually steeper than what humans follow, because humans gestate for about 209 months, 270 days, 270 or something there. Humans gestate for 270 and have an average lifespan of 80. Where other animals have a higher increase. Animals gestating, like we would be predicted to gestate for like 2 years. Could you imagine pregnancy for 2 years? Well, I mean, I don't know, that'd be crazy. Be like, gosh, that'd be nuts. Anyways, would you imagine pregnant people, things that gestate for like 40 days? Woo! That's, gosh. Oh God, please no. Well, it's pretty interesting. The variation in this is pretty interesting. You know, you just have to think about what is the data showing you? Like, what does the data mean? And so the humans they very much don't follow the relationship that other animals have. So humans are very much different in many, many, many ways. Many ways. Many animals are different, though. Our bunnies are different. So for the data, the R is currently this. This is the correlation right here. This is not a very strong. It's moderate. Moderate's about 0.5. Doesn't matter the sign. That's the direction, but it is positive. Do you think the association would be stronger if humans were removed? So removing humans is going to take the plot and make it look more like this, where with humans, it's going to look more like this. So it makes a tighter relationship. So it is stronger. It's not because it's easier to fit points to fewer lines. It's the slope and the correlation would increase. Slope is not strength of relationship. So my Pearson, it's more about the correlation. It is true the slope would increase, and I am showing that here visually with the black line, but it's stronger not because of slope. I mean, I guess you could, a steeper relationship, sure. Strength is usually a measure of correlation. Is there reasonable justification for removing humans? Sure, let's just talk about non-humans. Restricted to non-humans, cool. Here's the scatter plot and the regression. Okay, cool. We'll fit my line to it, like I did. Fit a black line. Comment on the strength. The association is, and we've got here perfect. Perfect only exists when all the points are where? Perfect only exists when all the points are where? On the what? So it can be perfect negative or perfect positive. Perfect only exists if they're all on the line. So it's not perfect. And it was kind of moderate before, but removing humans is going to make it moderate strong. So we can go moderate strong right there. Interpret the slope. This is similar to one we did previously. The slope is going to be this coefficient right here. The constant is the x, or the intercept, excuse me. That's where it's hitting the x-axis down here at about 89, or rather we should look at the one without humans. So it would be the interpretation of the slope, and I would say for each additional year in life expectancy, we expect the gestation period to increase by 13.03. So we expect it to increase by about 13.03. That is the coefficient of the x. And do look at this because the way this is displayed to you is the same way it is in jump output. From our previous question, and we got to go over here to this one, the previous question where we fit the line with capacity being explained by price, or reverse that. There we go, price being explained by that. The slope and the intercept are right here. Here's the intercept, and here's the slope, and they're down here with the estimates. So the intercept comes first, which they're calling the constant, And then the x variable is the second one. So know where those are at in your output. So we have said the slope is right here and it is increasing. A certain mammal has 15-year life expectancy, estimated gestation period. So what are we going to do right here? We're going to times 15 by the what to solve this and add it to the what. So what are we going to do? We're going to times 15 by the what? Exactly. We're going to times it by the slope coefficient because then that's like for each year it is living, we expect its gestation period to increase by this amount from a starting off of 89.6462. So we're just going to plug 15 in for the value of x and solve the equation. So that's the important thing to know right here is how to solve these and plug in values of x and make predictions. It might even give us a residual here at the end. So I don't think we talked residuals today at all. So we probably, hopefully it goes towards residuals if I remember properly. Okay, so it's going to have a prediction of 285.1412. Now here's what's important. When you do this, you probably want to zoom in on this plot a little bit right here. And we were predicting at 15 years. So if you go in and you go to 15 years and you fit a line, I wish it fit the line. Yeah, that looks to be about at, if you have a line fit to it, it should be about 285 is where it should be over here. Maybe it's a little bit higher. Maybe I just didn't draw that line right, but it's close enough to probably where it should be about at. The line should probably be going through about there, but that's pretty decent drawing, so looks somewhat accurate visually. So yeah, I think we're right on that. Do not round the final answer, then round to one decimal place as needed. Boop, there we go. And that's got it. Yay, we did it. Good question. That's a great question. No bane in this question. Would it be safer to always use the rounded values or just use the... we just saw that one. I think if it has you write the equation, use how it had you write it. If rounding ever gets you, let me know. If you ever are hit by a rounding, just let me know. Like, if the rounding you think was not fair to you, like if you entered in 0.2 here and it said you were wrong, it was like... It was this. Maybe, like, whoops, well, there's my Photoshop. So if it ever says you're wrong because of rounding, just let me know. Like, if it's like, you didn't round properly, so then just let me know. And all these fun things. Got all, like, my things here. Like, just, like, yeah, got the rock. All this fun stuff. Vendor stuff. Fun stuff. Ba-ba-ba. Oh, well, great work there. Well, I meant using... yeah, if you were to enter in the extra decimal here, just let me know. I wish it didn't count off. See, now I got 2 wrong. Like, if this were to happen to you, like, if these were your answers, I would totally count them. Like, so for everyone doing this right now, if you answered an extra decimal there, or if you rounded just a little bit weird right there, as the Rock always tells us, it doesn't matter. Don't worry about it. Because here's the big thing. We're going to switch to 474. Why I keep saying it doesn't matter is because when I'm actually doing this stuff, and let me go over here. 2 seconds, gotta clear out some data. When I'm actually doing this in practice, like I want to show you how I actually do these things, Blake. Like this is how I do predictive analytics. So I go right here and I make a model. So this is me making a regression model. So that is a linear model right there. If I want to visualize my model, I just say visualize model, and there's the visualization of my model right there. We got the model visualized. So now I can go in here and I can make predictions for my model just like this. There we go. I just made predictions for my model. And if I want to round those predictions, I can just go to round on my predictions and round them to 2 decimals, and I don't have to do it. It's all done for me. So, I mean, like rounding is important, but it's like, I just tell the computer to do it for me. Just like, here, make predictions for me. Here, round. And if I want to make predictions on new data, I can go here to, let's say, a data frame with data frame new data. And we're using weight. So I don't know what weight is supposed to be. Weight is, let's say, 2, 3, 5, and 10. And then we predict right here on new data equals data frame. And there we go. There's my predictions for those new values. And then we could store the row names, but there's the prediction for a car with 2. We're probably way crazy on weight. Yeah, because this is the horsepower it's supposed to have. Oh, cool. Yeah, I guess so. So these are the predictions right here, and yeah. Does that make sense, Blake? Like, this is why, like, I don't have to solve the regression equation. I could get my regression equation by typing coefficients right here, and I think Coef does it too. There's the coefficients, there's my intercept, there's my slope, and I could do all the legwork of saying that we are predicted horsepower is equal to the intercept times, see, this is so much longer, times the value of weight. So weight value, and so now I could take a, yeah, of course, because I'm just going to store it here. Now I could take a weight value, store this as like 2, and there's the predicted weight value right there, but all that work was done for me with the first value right here in there. So does that make sense, Blake? If I want residuals, I can calculate residuals just by saying residuals on my model. I just have to know what residuals are. It's how much we miss by when making predictions, like that right there. That's a big residual right there. That might be one of the biggest ones. But all this can be done just in seconds with code. If I want to look at an influence plot to see if there are influential points, I can just go to influence plot and look at the influential plots. That point over there is pretty crazy. Yeah, pretty interesting patterns. But this is why we code, because coding is just like, you can answer any question in seconds. You want to make predictions, you want to get residuals, you want to check your regression for issues, which is 320. Yep, we're going to do some 474 here. There we go. Is there any issues with this regression with the, check it out, QQ straight enough? And then we can look for no outliers. Ooh, we got some problems over here on the outliers. Ooh, look at that over there. Ooh, those points up there, pretty bad. So QQ straight enough. No outliers. Plot doesn't thicken. Guess what plot doesn't thicken is over here? 2,000 points, Blake. If you can tell me which condition is plot doesn't thicken. Which condition is checking plot doesn't thicken? Which of these conditions is checking plot doesn't thicken? There's 3 conditions that we did, and we just did this yesterday in 320. So which condition is plot doesn't thicken? Which condition right there is plot doesn't thicken? It's known as what right here? We call it homoscedasticity. Not the linearity. Good guess right there. Not the linearity. That's straight enough. Linearity is to check if it's straight enough. I'll tell you the 2,000 points. Linearity is straight enough. Normality is going to look oftentimes for outliers. So the condition for plot doesn't thicken is there an equal spread of the points? The equal spread. Does that make sense? So we'd look at this plot right here. I wish the dots were bigger. We'd look at that plot right there and say, is there an equal spread of those points? This is a little bit easier to see like that. And it looks mostly like there's an equal spread, but also the p-value right here indicates there's not a problem. Yeah. Now you got it. No, good work right there. So that's where we also use, 201 concepts of QQ straight enough, no outliers, plot doesn't thicken. We use it in 320 and 474. I had to cancel afternoon office hours today. Let's go look at some 1D here real quick. You ready? Let's switch over. We got I'm going to send out the announcement to class, and let's throw this in the video because I'm going to be gone later today. So homework 6, 1D. Okay, because I think 1D is the for loop, which is a big question. Morgan, we're going to jump into that question here. We can just postpone 201. No, we can't postpone 201. We can't do that. No. Give me a second. I'm loading up question 1D. Okay. You're welcome, Morgan. Let me send out an announcement here. I'm going to put a little chill music while we get this going right here. Getting 201 going. Okay. Gonna send the announcement about Watch Class Live. If I don't send an announcement, oof. We get a lot of people don't show up. And we got to make sure. Class in 18 minutes. We got about 8 minutes to this. Class in 18 minutes. See you soon. Click here. I sent it to 320 one day, or 474, I think, by accident. People were like, what is going on? Okay. Let me go grab the 474 assignment. Wait, that's summer. Okay. 474. Okay, here we go. RMD. I freaked out when I saw the midterm review. Oh, you saw ones for 201. Okay. Here we go. Let's talk about a little bit of 474. Okay, I think 1D is the for loop. I think it is, if I know correctly off the top of my head. Okay, here we go. It is. So the key for this one, this is a pretty complicated one. The key for this one is making linear models. So it's kind of verging into that idea, but you're making a linear model looping through all of your things. And you have to do the steps right here because you'll notice right here, you're making a linear model for just an XY combination. But the way in which you make it, especially when doing this, is the key right here. The first variable in the prod launch data set is your what variable. The first variable in the prod launch data set is your what variable. Let me clear this out. The first variable in the prod launch data set is your what variable. So in the prod launch data set, the first variable is your what variable. Now I know it's profit, but that's the what variable. So this is the key theory behind making this for loop, and it's a nested for loop. So the first variable is the what variable. I know it's profit, but profit is the what variable. And the other variables kind of indicate to you what they are also. The first variable is your what variable. We have two things. We have an X and we have a what. It's the predicted. I would say Y variable of interest. Morgan, 1,000 points. Keep up those answers. I like to say Y variable of interest because it's the one we want to understand. It's the why. Why is it happening? Sometimes people call it the dependent variable. X is the independent. Mathy terms. I always like to say this is the one we want to understand. This is what we're interested in. This is the Y variable. So the Y is the one that is being solved for. The X's are the explanatories. So the data set's a little bit clearer on what the X's are and what the Y variable is. If we just put a little Y on that, make a little more sense. So if you look at this right here, what does this code say when we're taking data from the prod launch data? If you look at this right here, we're only taking what's. So if you look at the way this is running this code only does what right there. And what does that code do? What does that code do? We can actually improve it a little bit, I think, which I think is a better way of doing it, if you ask me. Because we have X4 right there, right? So we can actually do a little work on our own. Only returns 2 columns. Well, three, but it returns the Y variable of interest and the X is right there. But watch this. What if we write it this way? If I write 5 as 6, no, it's X4. So it should be 4 plus 1. There we go. And 15 plus 1. So the reason I wrote it this way, why would I rewrite it and re-express it this way? Why would I rewrite it? Why would I rewrite 5 as 4 plus 1? This is going to be helpful for the for loop later on. So this is it doesn't tell you to do that right there in the problem, but that's going to be helpful for the for loop later on as we loop through and we select certain X's. So why would that be helpful to re-express 5 as 4 plus 1? And think about where it's at, as in right here. This is the 5th variable in the data set, but what? Why would I express it as 4 plus 1? Why would I express the 5th variable as 4 plus 1, which will help when we're assigning things in our matrix? So 4 kind of means it's the 4th X, right? So now you see it's the 5th variable, or the 5th column, which is the variables. So it's the 5th variable, and then calling it 4 plus 1 is going to be helpful because now if I want to get the 7th variable, I can just say 7 plus 1. Does that make sense? So now we have, or do we show it? That should be right. Oh, I scrolled all the way up. I meant to clear the screen, scroll up. So now to get the 7th variable, I can do 7 plus 1. I have the 7th X now. Does that make sense right here? So now rather than doing 8 and thinking, oh, wait, 8 is 7, I can think, oh, I just put 7 right there, and 7 plus 1 is the 7th variable because everything is offset by 1 because the Y is at the start of the data frame. Does that make sense here? Why expressing it this way is going to help for later on when I'm storing these values. So the key to this, and it kind of walks you through it. The key to this, and we haven't split anything up yet. We haven't made training. We haven't made a holdout because the for loop's the real hard part about this. So Brian is talking theory. Make sure to follow all steps. You want to make sure you do like the training and holdout right here, which is nice and easy. We covered that in last class, how to do training and holdout, how to split it up with the set seed, how to do the sample 1 through the number of rows, the certain percentage. So check out last class. We totally did that in the activity. Finishing the activity tomorrow. So with this right here, if you want to create a linear model, when we do a linear model, the format for a linear model is save into M. We usually call it object M just for model. We say LM, a linear model, and we have our Y variable of interest, X, tilde X, comma, data equals, and then we have the name of the data frame. Well, you can actually limit your data frame by doing the following. So now when we choose the data frame, we can say take all the X's and take profit as the Y, because that's the first column, but this is only going to make a model now with what? Think about if I limit my data frame, you're seeing the data frame limited down below. So this will only make a model with what and what. Because of the way I've written this right here, which is going to be the skeleton, you know he's back. He's always there. He's always chilling out. Because of the way I've written this, when I make this model, exactly, there's only going to be certain variables in this model. And the certain variables in this model will be X7 and X15. And expressing it this way right here is going to really help as we change them to like I's or J's, because that's going to say, well, we're just going to go through 1 through 20 because there's 20 X's. Does this kind of make sense? I'm kind of talking about how to write this right now. We want to go through 1 through 20 on the one variable and 1 through 20 on the other variable, but there is a problem. The problem we have is if we have right here, this is a huge thing I'm writing right now. If I is not equal to J, if we do that, I haven't written this full thing out. You got to solve the rest of it. If I is not equal to J, then store into M this. However, if I is equal to J, we don't need to take the variable twice, and we would just take the one variable. That should be right. Looks accurate. You know, you can use if and else's if you want. Sometimes I just use two ifs. But this is not the full for loop yet, but it's a major component of it. And you want to be using your train data, I'm pretty certain. So I don't even have the train data right here, but this is the major component right here. Good to see you here, Evan. So does this make sense? Because if I is equal to J, does that make sense? So, well, you got, this is, if you've been following through the steps and you're stuck, this might push someone over them. Oh, okay. Because I haven't written the for loop component of it yet. Let's just see this code in action right here and see how it creates a model. So if we create this right here, here's the model, and look, X7 and X15. But why am I doing this right here? Why would I say if we're choosing the same variable, only an hour and 9 minutes late? No worries, Evan. If we're choosing the same variable, we don't need to choose it twice. And that's why I have just the variable in there one time. Like as we cycle through, you could skip and stuff. I guess you could say next. I don't know. There's a lot of ways. No. I think you want to choose it. You want to show if X1 and same variable. It's a one variable model. Or do we ever write those with NAs? I don't know. You could, there's a lot of ways to do this. So many theoretical ways to do this problem. But does that make sense here, Morgan? I hope this is a big help. This right here, the if it's the same variable, like that's a major component right there. Like if they're not the same variable, then choose both of them, which is the way that reads. If they are the same variable, then only choose one. And then you need to do a nested for loop. So you'll do a nested for loop. Yeah, that's what we want to see. That's why I always want to like do part of it. This one's a very hard one not to like to do like an alternate version of the problem. It's like now you want to go in here and you want to make a nested for loop, but you don't want to try writing your nested for loop without, you know, from scratch. You want to think about how this would permeate through, and you also need to save it. And the steps right here are really good in how it has you walk through and save certain values, and you'll be populating this matrix right here. So the matrix you're getting, you're populating it with all the values. You can see right here of the different models and how they do. So you're doing all the combinations of the X values. So you will get a populated matrix. Make sure to take your training, make sure to take your holdout, all that good stuff. Really good. It's a really great question, and it's a pretty tough one, but the steps really help. but also the code we've written up here is a great help too. But I gotta go because we gotta do some class here. See you soon, everybody. Bye for now. Bye, Evan. Bye, Blake. Bye, everybody. Bye.